New AI models are dropping pretty much every single day, but how do you separate the real deal from all the hype? How do you actually prove that one model is better than another? Well, that's what we're diving into today, the absolutely essential skill of AI evaluation, figuring out how engineers measure what makes an AI model truly great. So here's our game plan. First, we're going to tackle the big question. What does a good AI even look like? Then we'll get into some basic correctness checks, explore the wild idea of using AI to judge other AI, and then jump into the competitive world of model leaderboards. We'll wrap it all up with the single most important mindset you need to have as an engineer.
And this, right here, is the core challenge. Think about it. When you're building an AI application, you have literally thousands of models to pick from. A slick demo just isn't going to cut it. You need cold, hard data to prove your choice is the right one. So how in the world do we get that data?
And that brings us right to what we call the measurement problem. Because figuring out what good even means, that's not just a vibe or a matter of opinion. It's a real engineering challenge, and it demands a systematic approach.
Look, anyone can whip up a demo that looks cool for a minute. But a demo is not a product. The real work, the heavy lifting of AI engineering, is moving past that whole, it feels right stage. It's all about finding objective, repeatable ways to measure performance. Anything less than that is basically just guesswork.
All right, so where do we even begin? Well, you start with the basics, right? Let's kick off our quest for correctness by looking at the simplest methods, the ones where there's a clear, undisputed right or wrong answer.
First up is something called functional correctness. This is perfect for tasks where there's zero gray area, like generating code. The concept is super simple. You give the AI a problem, it spits out some code, and then you just run tests on it. Does the code actually run? Does it give you the exact result you were looking for? It's a straightforward pass or fail, no ambiguity.
And the whole process is just a simple three-step dance. The model generates the code, you hit it with a bunch of automated tests to check all the different scenarios, and you get a clear result. You know, if you've ever used a coding platform like LeetCode where your solution gets graded automatically, then you've already seen functional correctness in action.
Okay, so what about regular old questions? For those, we can use a method called exact match. And yeah, it's pretty much exactly what it sounds like. We have a question, we have a golden, correct answer in our data set, and we just check if the model's output is a perfect match. Sounds simple, right? Well, mostly. And boom, this is exactly where these simple methods can totally fall apart. Let's say we ask when Anne Frank was born. The reference answer we have is just 1929. But what if the model gives us September 12th, 1929? Technically, yeah, it's got the right year in there, but the full date? That's just plain wrong. So it shows that even something that sounds as simple as an exact match isn't always so clear.
Okay, so since the simple stuff has its limits, let's level up to something way more sophisticated. This is a really modern technique that's become super popular, using AI to judge other AI.
The core idea is kind of brilliant, really. You take a beast of a model, like a GPT-4, and you basically give it a new job description. You're a judge now. You show it the original prompt, you show it the other model's response, and you ask the judge to score that response based on some very specific criteria.
And this is where evaluation gets a lot more nuanced. We're not just asking, is it right or wrong anymore? Now we're asking things like, is the answer grounded? Is it actually backed up by the source data? Is it truly relevant to what the user asked? Is it actually helpful? Measuring these qualities is incredibly powerful, but it also creates a brand new challenge. And that challenge is ambiguity. Just take a super important metric like faithfulness. You've got these three major tools, MLflow, Ragus, and Llama Index, and they all measure it completely differently. One uses a 1 to 5 scale, one uses a binary 0 or 1, and the other just says yes or no. This lack of a single unified standard, it is a massive headache for engineers. All right, so far we've been looking at answers one by one. Now let's zoom all the way out and see how this whole thing plays out in the wild. Welcome to the public arena, the AI model leaderboard. So the big idea here is to forget about absolute scores for a second and focus on relative rankings. You've got platforms like the famous chatbot arena, and what they do is they put two anonymous models in a ring, give them the same prompt, and then they turn to the crowd, the users, and ask one simple question: who won? It's a straight-up head-to-head battle for user preference.
And when you do this, not once, not twice, but hundreds of thousands, even millions of times, you end up with this enormous data set of wins and losses. This entire match history then gets fed into a rating system to create a public leaderboard, ranking all the models from best to worst, all based on what people collectively think.
But, and this is a big but,
These leaderboards are far from perfect. Voters have biases, right? Maybe they just like longer answers, even if they're wrong. The prompts themselves can be kinda silly and not reflect how people use these things in the real world. But honestly, the biggest issue is that the rankings are all relative. Being number 1 just means you're better than number 2. It says absolutely nothing about whether you're actually good enough for a real-world, professional job.
Which brings us to our final and definitely most important section. All these methods we've talked about, they're just tools in a toolbox. The real secret sauce is how you use them. This is what separates the hobbyists from the pros. It's all about the engineer's mindset.
Okay, and this right here is probably the most important thing you'll hear today: evaluation-driven development. The rule is incredibly simple, but powerful. You define your metrics for success before you do anything else. You always start by asking, how am I going to prove this thing actually works?
And trust me, this is not just some academic theory. The most successful AI apps out there today are the ones with the absolute clearest ways to measure success. For recommender system, success means users are clicking and buying more. For fraud detection, it's literally about the dollars and cents you save. For code generation, it all comes back to passing those functional tests. The value is something you can actually point to and measure.
So I'm going to leave you with this one thought. It doesn't matter if you're a student just starting out, a hobbyist playing around, or a pro in the field. This is the question that separates a cool little demo from a truly valuable application. Before you build, before you even write a prompt, how will you measure success? That right there is the key to building AI that actually matters.